Good morning everyone. Today in this live lecture we shall study the standard forms, some standard types. In that some standard types, that is a standard form 4 of the non-linear partial differential equation, which can be solved by the Charpit's method, but that is a particular form. So we can known that form as Clairaut form. This is the particular standard form, that is a 4 number, which is denoted by or which is represented by the Clairaut form, which is also formed due to the Charpit's method. That is a particular type of a non-linear partial differential equation. See this is the first method. You know that the Charpit's method is a famous method which is used to solve the non-linear partial differential equations. This is the family of partial differential equations which we have to add in the solution of a Charpit's method. So 1, 2, 3, these are the 4 standard forms which we have studied, and we have solved the number of problems based on this. Now this is the 4th type, that is a Clairaut form. If the partial differential equation of the type z is equals to f, z is equals to px plus qy plus g of p comma q. So we will get the solution in this way. This is the short note. Actually these are the short note, but we have to discuss this type 4 in detail. So we shall move towards the some standard type. In that some standard type, the type 4, that is also known as a Clairaut equation. So Clairaut equation or Clairaut form, we shall define the first that form and then we shall move towards this. Okay. आता पहा काही अडचण, if you have any doubt then you can ask continuously. Okay. A first order partial differential equation partial differential equation is said to be Clairaut equation or Clairaut form if it can be written as z is equals to f of px plus qy plus function of p and q. You can write any function of p and q. So this type is known as, आता f म्हणण्याच्या ऐवजी आपण काय करू, याला g घेऊ किंवा h घेऊ, g of p comma q. A first order partial differential equation is said to be Clairaut form or Clairaut equation, partial differential equation, if it has a special form, it has a standard form, z is equals to px into qy plus qy plus again a function of p and q. Again a function of p and q means we have to write p and q, combination of p and q. So this equation is called as a Clairaut equation, or this form is called as a Clairaut form. This is the standard form type 4 which is obtained from the Charpit's method. Now how to solve these equations here? Now by using this method we can solve. Here we consider the function f is equals to, how we can write? We can write px plus qy plus g of p comma q, which is minus z. So we can represent this because we have to use the Charpit's auxiliary equation. So we have to represent this equation f in the form of px plus qy plus g of p comma q, which is equals to already 0. So this is the form which is equals to 0. Now you can use the Chapman's auxiliary equation we have. समजून घ्या स्टुडंट, ही मेथड समजून घ्या, खूप इझिली आहे, पण यू हॅव टू अंडरस्टँड हाऊ विल गेट दिस सोल्युशन मेथड. वी हॅव Chapman's auxiliary equation. So dx divided by fp, which is equals to dy divided by fq, which is equals to dz divided by p into fp plus q into fq, which is equals to dp divided by minus fx plus pfz, बरोबर आहे का स्टुडंट, विच इज इक्वल्स टू dq divided by minus fy plus qfz. This is the Chapman's auxiliary equation, or it is also known as the Chapman's auxiliary equations. You can make different equations by comparing different fractions. You can make number of equations, 1, 4, 5 equations we can make. So it is also known as the Chapman's equations. So you can write these equations as the Chapman's equations are. याला equations सुद्धा म्हणता येतो. This is the combinations of this equation is the combination of equations. Now here, now see this, we will get the value. हे समजून घ्या रे. fp, you have to calculate fx. What is the value of fx? You have to take the partial derivative of f with respect to x. Then what is the value? So it will be p. fy, हाँ चला सांगा, fy, what is the value of fy? Partial derivative of f with respect to y, which is given by q. So fz, which is given by minus 1, okay. Then fp, partial derivative of f with respect to p. Again here p is x and again gp, means x plus g of p. G is a function of p and q, so we can write x, px a derivative x, gp. So fq we can write, fq ला कसं लिहिता येईल? Partial derivative of f with respect to q. There are two terms of q. First is qy, so its derivative is y. Again there is a combination of function of p and q, that is denoted by g. G is a function of p and q, so fq means y plus g suffix q. Now put into 2 मध्ये ठेवा आता. So we will get, कसं लिहिता येईल मग? This implies that dx divided by x plus fp, dy divided by y plus fq, बरोबर आहे का रे स्टुडंट्स? dz divided by p into fp, p into fp means x plus fp plus q into fq, y plus fq. Again see this, dp divided by f minus fx plus pfz. So we can write dp divided by, this is very important, dp divided by fx means p, fz means minus 1, so minus in a bracket p minus 1 into fz means minus 1 and p into fz means minus p. Is it okay? So dq divided by minus q minus q. So we can write dx divided by x plus fp dy divided by y plus fq dz divided by f in a bracket x plus, sorry, p in a bracket x plus fp plus q in a bracket y plus fq. Is it okay? gp का कुठं gp रे? Okay, okay, 1 minute. fz means 1, fq. Okay, write gp, we can write, is it okay? Right, very good. This is the gp. fp नहीं है, gp है ना. fp means x plus gp. Okay, no problem, you can write this. Okay, you can write this as a fp means gq. Okay, gp. Is it okay? Right, very good. gq, gp, gq. Is it okay? gq, very good. So we can write x plus gp plus q into gq. No problem, which is equals to, this is very important, dp divided by 0, which is equals to dq divided by 0. So we can write the, if we take the last two fractions, taking 4th and 5th fractions, then we get dp divided by 0, which is equals to dq divided by 0. This implies that dp is equals to 0 and see here dq is equals to 0. So by integrating, dp च integration p, 0 च integration 0 with a constant suppose a. Similarly, by taking the integration, dq च integration q, if we take the constant b. So we get the values of, if we consider these values as a and b, suppose a and b. Now putting these values, see here, putting these values p is equals to a and q is equals to b in the equation 1, direct you can put in the equation 1, then you will get the solution z. There is not necessary to write in the equation dz is equals to p dx plus q dy, because we have given only the equation in terms of z. Z is equals to px plus qy plus g of p comma q. Then we can write directly solution by using 1. So put in 1. So put in 1. Then we get, what is that? Z is equals to ax plus by plus g of a comma b. Say this. Put in this equation 1. Means z is equals to, p means ax, q means by, g of p comma q. This is the complete solution. This is the required solution. So this is the complete integral of the equation. See this is a complete integral. This is a very simple idea. Complete integral of the equation. What is that equation? Z is equals to px plus qy plus g of p comma q. म्हणजे हे जर डिफरन्शियल इक्वेशन असेल, इफ द डिफरन्शियल नॉन लिनियर डिफरन्शियल इक्वेशन विच इज इन द फॉर्म z is equals to px plus qy plus g of p comma q, then we get its solution is z is equals to ax plus by plus g of a comma b. That means we can write direct solution. So this is called as a Clairaut equation. याला काय म्हटलं जातं? Clairaut equation. आता याचं आपण सिंग्युलर इंटिग्रल सुद्धा काढू शकतो, पर्टिक्युलर इंटिग्रल, पर्टिक्युलर सोल्युशन सुद्धा काढू शकतो. सो यू कॅन राईट द नोट यात व्हॅल्यू ठेवा, ए आणि बी च्या व्हॅल्यू आपण कॅल्क्युलेट करू शकतो. सो वी कॅन राईट दिस. सपोज दिस इज अ इक्वेशन 1 2. सपोज दीज आर द इक्वेशन्स 3, इक्वेशन 4. आता नोट टाका. सी दिस नोट. द सोल्युशन ऑफ PD Z is equals to Px plus Qy plus G of P comma Q is, what is that solution or complete integral? You can write is Z is equals to, what is that, Ax plus By plus G of P comma Q. Now we can find the singular integral. We can find the singular integral. So differentiating, suppose this is equation 1 and 2. Differentiating equation 2 with respect to A and B. With respect to A and B. So if we take the integrating with respect to A, Z is the constant term, in that there is no, so we can write 0 equals to Ax derivative yeto x with respect to A means A into x plus By is 0, that is a G dash of A comma B, itha AB. So okay, A comma B, G dash of A comma B, 0 is equals to y plus G dash of A comma B. Now we can eliminate. So from this is a 3 and this is a 4. So we can eliminate G dash of A comma B. Then we get singular integral of PDE1. This is called as a singular integral. This method is called as a singular integral. Actually, the partial differential equation is Z is equals to Px plus Qy plus G of P comma Q. Then its complete integral is Z is equals to Ax plus By plus G of A comma B. But here A and B are the arbitrary constants. So we can write this as a general solution. So we can obtain the particular solution in this way. Differentiating equation 2 with respect to A and B, then we will get this result. And eliminate A and B, we will write the particular solution. This is one method we can obtain. In the Clairaut method, in the Clairaut form, we can obtain the particular solution also. Okay. So we shall take the examples based on this. आता example घेऊ, खूप simple आहे. Example. First, find the complete integral and singular integral of the equation of the partial differential equation Z is equals to Px plus Qy plus P square plus Q square. See this. Is it okay? So now we can solve this. Given non-linear PDE is Z is equals to Px plus Qy plus P square plus Q square. So you can write this is Z is equals to Px plus Qy plus, you can take this P square plus Q square in the bracket. This is a function of P and Q. So this is in the form we can write. So this equation is in the form, this is a particular type form that is called Clairaut form, is in the form denoted by known as Clairaut form. So it is denoted by Z is equals to Px plus Qy plus G of P comma Q. Then we know that we can obtain the solution in the form here. So this implies that P is equals to A and Q is equals to B. So therefore the complete integral, सांगा रे आता याचं कंप्लीट इंटिग्रल काय डायरेक्ट लिहायचं, याचं सोल्युशन करत बसायचं नाही. It is not necessary to write the Charpit's equation. It is not necessary to find the values of P and Q, Fx, Fy. You have to use direct Charpit's, that is Clairaut method, Clairaut equation directly for this. So we can write the complete solution is, what is that? काय तो solution? Who can tell me? Z is equals to Ax. सांगा रे, what is the solution of this? Z is equals to Ax plus By plus G of A comma B, G of A comma B, which is denoted by G of A comma B. But G of P comma Q means P square plus Q square. So we can write Z is equals to Ax plus By in a bracket P square plus Q square. We can replace this P square plus Q square as A square plus B square. So Z is equals to Ax plus By plus A square plus B square. This is the complete integral. हा ऋतिका तेटेवार ब्रॅकेट मध्ये PQ नाही येत. सारिका बोळेगावे, व्हेरी नाइस. So this is the complete integral. This is the complete integral. But we have to also find the singular integral. Also, this is complete integral of 1. Equation 1 चा complete integral आहे. Now we have to calculate, now to obtain the singular integral, differentiating equation 2 with respect to A comma B. A आणि B ने डेरिव्हेटिव्ह घ्या. So it will be 0 is equals to Ax चा डेरिव्हेटिव्ह with respect to A is x plus By चा 0 plus 2A. And if we take differentiating with respect to 0 is equals to, so By चा y plus लेफ्ट साइडला याची टर्मच नाही म्हणून 0. Z चा डेरिव्हेटिव्ह विथ रिस्पेक्ट टू A इज 0, Z चा डेरिव्हेटिव्ह विथ रिस्पेक्ट टू B इज 0. So to be, now from this equation we can write, so it will be x is equal, we can find the value of A is equals to minus x by 2, and from this equation, and you can write B is equals to minus y by 2. A is equals to minus x by 2, B is equals to y by 2. So putting these values in equation 2, ओके काळे, प्रियंका काळे, व्हेरी गुड. सद्दाम, नेहा शेख, वडवळे, सारिका पराळे, प्रगती पाटील, क्षीरसागर, नितीन, very good. Now put this value, so we will get the singular integral Z is equals to, A means x by 2, so minus x square by 2, B means minus y by 2, so put this in equation 2, so minus y square by 2, plus A square means x square by 2, plus B square means y square by 2. Okay, so A square, square है now, so it will be A square means minus x by 2, its square means x square by 4, so it will be b square means minus y by 2, its square means y square by 4. So x square by 4 minus x square by 2, so it will be minus x square by 4 minus x square by 2 plus x square by 4, it will be the काय येईल मग power a. So x square by 4 minus x square by 2, so LCM is 4, so x square minus इथं काय येतं रे 2x square, that is a minus x square, okay, minus y square by 4. So we can write z is equals to minus in a bracket x square plus y square divided by 4. So this is the required singular integral. This is the required singular integral. आणि सद्दाम पहा, सद्दाम तुम्ही जो प्रॉब्लेम दिलेला आहे, मला वाटतं मी थोड़ा क्लियर नहीं बघितला. एक्चुअली सद्दाम आपने जो प्रॉब्लम दिया हुआ है वो आई एम नॉट सीन दैट क्लियरली, बट यू कैन सॉल्व दिस इन दिस मेथड और यू हैव टू सॉल्व बाय यूजिंग द चारपिट्स मेथड एंड okay. 1 minute. So this is the required singular integral, z is equals to minus x square plus y square divided by 4. Okay, so we can write this. Yes, now okay, now we shall move towards this. Okay, ठीक है. Now we shall move towards the second problem. What is that second problem here? 1 minute. Second problem. Find a complete integral of the PD z is equals to px plus qy plus log of p into q. Okay, so we can write this equation. Find a complete integral of partial differential equation this. So given PD z is equals to px plus qy plus log of p comma q. Suppose this is equation number 1. Now you can write in the form of, so you can write in this form of, okay, so equation this one, see here, z is equals to px plus qy plus log of pq. Now we have to convert this in the form of z is equals to px plus qy log of p plus q. So you can write this z is equals to px plus qy log of p comma q. This PD is in the form of z is equals to, what is that, px plus qy plus g of p comma q. Clairaut form. So we can write this. So its complete integral is z is equals to ax plus by plus g of p comma q. So g of a comma b. So z is equals to ax plus by plus log of a comma b, that is written as ab. So this can be written as a second. So from 192, we can write सो जाऊ द्या, फ्रॉम 1 and 2 ची गरज नाही आहे. सो दिस इज द complete integral. This is the complete. You can find the singular integral. आता याचं तुम्ही singular integral सुद्धा find out करू शकता. Okay, so how we can write the singular integral of this? So we can write the singular integral in the way, so differentiate equation 2 with respect to x and with respect to y. So we can write, so this is from equation 1 and 2, to find the singular integral how we can write this? See this, differentiate equation 2 with respect to a and b, with respect to a and b. Okay, तर याला कॅल्क्युलेट करा. What will be the reason? We will get the solution. 0 is equals to x plus y चा 0 log of a plus b चा डेरिव्हेटिव्ह 1 upon ab into log ab चा 1 upon ab. ठीक आहे. So also 0 is equals to y plus 1 upon ab into, हाँ एक मिनिट, log ab चा डेरिव्हेटिव्ह 1 upon ab into b and 1 upon ab चा, परत ab चा घ्या, b येतो, इथं a येतो. So this implies that b will be get cancel. So x is equals to, we can write a is equals to minus 1 upon x. This implies that b is equals to minus 1 upon y. So we can write in this way. This implies that z is equals to px plus qy, means ax. Ax means a, we can write this 1 upon x. ठेवा values, put in equation 1, so it will be the put in 2. बरोबर आहे का रे? Put in equation 2, so z is equals to a into x. A means 1 upon x, divide by x, so it will be minus 1 upon x into x plus minus 1 upon y into y plus log of minus 1 upon x into minus 1 upon y. So it will be log of ab means 1 upon 1 by x into 1 by y. Is it okay? So it will be the minus 1 plus log of xy. So the final answer is the log of xy minus 2. This is the required solution. Minus 1. Okay? कुठं minus 1 रे Mansur Saddam? Is it okay? So we can find the solution. This is the singular integral. This is the singular integral. This is the singular integral. Okay, so we can write this. So we can write this in this way. Now we shall move towards the homework. Assignments करा, homework करा. So आता याच्यानंतरचे जे जॅकोबिन मेथड ते आपण उद्याला सुरुवात करू. अगोदर याच्या टाईपचं होमवर्क घ्या, बुकमध्ये दिलेले आहेत होमवर्क. 1 minute. Okay, so you can write this. Homework are z is equals to px plus qy minus root of pq. Second, z is equals to px plus qy plus root of p square plus q square. So third, pqz is equals to p square qx plus pq square y plus p square plus q square. Dividing by pq kara, dividing by pq. Hint of this last problem is dividing by pq. Okay, now you can solve. One minute. So it will be z. Okay, next complete integral. Next, okay, p square 4 pq into z is equals to p square in a bracket xq plus p square plus q square in a bracket yp plus q square. Okay, so again you have to divide by this z. So it will be आता याचं कसं येईल पहा, z is equals to, you can write xp plus yq plus p raised to 4 plus q raised to 4 divided by pq. In this way we will get the solution. Next, fifth, z is equals to px plus qy plus pq. Okay, तर हे सर्व प्रॉब्लेम्स तुम्हाला सॉल्व करायचे आहेत. यू हॅव टू सॉल्व ऑल दीज प्रॉब्लेम्स. ओके, हां सद्दाम बरोबर आहे. आता होमवर्कला तुम्हाला प्रॉब्लेम देतो, यू हॅव टू सॉल्व धिस इन द होमवर्क. ओके, हे टोटल 4 पिट्स मेथडनं सॉल्व करायचे प्रॉब्लेम्स आहेत. ॲक्च्युअली यू हॅव टू सॉल्व धिस. दीज आर नॉट इन अ स्टँडर्ड टाईप. You have to solve by any method. You have to solve this by any method, then you can write this in this way. Okay, so solve this equation. You can use the Charpit's method, you can use the standard forms. Okay, now we shall stop here. Namaskar, goodbye.